Determine a function that represents a product. All right, we already have that. We took our two numbers. Remember, we had two numbers in our baskets. What was true about those two numbers? What are some things that were true about those two numbers? They both had to be positive. What else was true about my two numbers? No, they did not each equal 45. Change your wording. I know what you meant. It's just that you didn't say what you meant. Give somebody else a chance though. All right. What else did we know about our two numbers? They were both positive. My face-to-facers are giving me the silent treatment. Apparently they're mad at me. Zoomers, what do you guys think? What do I know about these two numbers other than the fact that they're positive? Their sum is 45. Do you see the difference there, Sierra? Okay, to say they are 45, to me says this one's 45 and this one's 45, and that's not true. Their sum, when I add them together, is 45. All right, so Dylan, were you gonna ask a question in there?
No, I was just trying to remember everything.
Yeah, that's what, I'm trying to remind everybody. Okay, so then what we had is, all right, so we've got our product, we have our function written for the product, where I took my first number x and I multiplied by my second number 45 minus x, and that's what I have for part C. I'm in the process of working on part D, and it says determine analytic. What does analytically mean again? I explained this last time. Show your work. Okay, so this isn't something that you should be graphing on the calculator. In other words, you can use the calculator to add, subtract, multiply, divide, but you shouldn't be graphing on the calculator. So determine analytically the numbers whose product is a maximum. Now, last time we talked about anytime we say the word maximum or we say the word minimum, what should our brain automatically be thinking? Vertex. Vertex. Oh, wait, we've got a shortcut for finding vertex. Okay, so let's see. Somebody look at their notes and tell me, what is the shortcut for finding the H value of the vertex? Let's see, I'm going to pick on Blake. And you're muted, so make sure that you unmute yourself, Blake.
Is it like B over 2?
Can you repeat that, Blake? I'm not hearing you.
Negative B over 2A?
All right, he says negative B over 2A, and he is correct. That's going to give me the X piece of my vertex. Okay, now, here's where I moved a little too fast through the question last time. Once I get that value, normally we plug and chug to get the Y value, right? Well, the Y value is my product. The Y value is the answer to the second piece. Okay? The Y value is going to be that maximum product. So yes, I want to find that, but before I find that, I need to find my two values first. So the H value gives you one of your baskets. What's the easiest way to find the other basket? If this basket's value was X, what was this basket's value again? No? 45 minus X. So once I find this guy's value, all I need to do is get 45 minus this guy's value, and we'll have our second number, okay? So I've mapped it out for you. I want you guys to find, first of all, what are my two values, and then go find the maximum product by plugging and chugging, okay? It's okay if you're stuck. Ask people around you, all right? Collaborate, just social distance while you collaborate. Let me go get my Apple Pencil since I forgot it.
I'm dropping this class today. That's what I was thinking. It's like stupid people math in high school, and then they get an advanced one. I'm like, what happened there? I literally went from probability and statistics to this. I had to take math 101 and then math 102, and now I can do this.
See, I skipped
So that's
all
what
of
I'm
that.
kind of like, and then you
I
see, and
skipped
then
all
she
that
says stuff like, you should learn some math.
I'm like,
I'm dropping it today.
no, I need it for my freaking degree, and I'm like, what does this have to do with anything that I'm doing?
That's what I'm saying, like, why do you know the maximum value of the product to give somebody some, you know, a saving bag?
I hired a tutor and she studied to be a math professor, and we were struggling on a question the whole the other day. And I was like, if you think calculus is experiment,
I know this stuff.
I don't know.
I can add up, and I don't know how to do a question, I skip it. Or I'll put zero in and I'll just shoot answer chickens or find checks.
I'm doing that to figure out homework.
See, I didn't have math. I didn't have math.
Yours and your. Well,
See, and the thing is not the explanation.
I wouldn't say that burn.
That's one of the.
Why, that's
Did you?
I know people, they just say I'm called math. Like,
That's not the oil, that's the one it's
but then next time I'm gonna do that, the problem is the only thing, but I'm trying to do this college at the same time.
I'm so sorry.
I feel bad, but I'm like, I don't know how to do these. Like, there's stuff I should have learned that I don't know because I wasn't in math when I wanted to.
Did you do it?
I was strict math. Yeah, I didn't either. I'm struggling.
How are we doing?
I'm just gonna like guess though, are we supposed to do 45 minus 45 over 2? Or am I doing that wrong?
Let's find out. Okay, so I've already got the H value up there. So automatically one of my values, what's in the first basket, is going to be my 45 over 2. Okay, if you had said it was 22 and a half, that's the same thing. If you had said 22.5, that's the same thing. Okay, so that's fine.
So you accept decimals too, because I don't want those. That's fine.
It depends. So occasionally, that's not a blanket statement, that's true. Okay, the homework does accept decimals, but you do have to read the blue instructions. Because if the blue instruction says enter your answer as an integer or a fraction, that's not a decimal. Integer is a whole number, and of course a fraction is a fraction. So in that case, it wouldn't accept it, but the directions told you it wouldn't accept it. You see what I'm saying? So you just have to read the directions, because I've tried, and when it doesn't say, I've tried entering in multiple things, decimal, fraction, etc., and it does accept them. So it just depends on the directions.
So are you gonna have like certain things in the test that it has to be a fraction or?
Maybe. But your calculator will do them.
Yeah.
Okay, your calculator will do them. So 45 over 2, that one makes sense. I mean, like there wasn't any reducing or anything to do. We just plugged and chugged. Well, actually, there's hardly any chugging. We just plugged. All right, now, to get the second number, we don't want to plug it in yet. That's going to give me the maximum product. That's not what I'm looking for yet. I just want the second number out of my basket. And so if the first number was X and the second number was 45 minus X, then yes, Dylan, 45 minus 45 halves is going to give me my second number, which is 45 halves. So in this case, my two numbers that caused a maximum product, they're exactly the same. Is that always going to happen? No, not necessarily. Okay. Now, go look for the maximum product. Now, go look for that Y value. Okay, so this is where we're going to plug and chug. So we've got P of, your calculator will do this, 45 halves. It's going to equal negative 45 halves squared plus 45 times 45 halves. So yeah, it looks ugly, but if your calculator does all the work, and if you're wondering how to do fractions on your calculator, push the math button and the very first thing in the menu is frac, F-R-A-C, it'll change things to fractions. Okay, so that's how you can do fraction mode then in your calculator. All right, so when you type this in, oh, I'm going on memory. I think it's 506, help me, 0.25. .25. So again, just as a recap here, think of this visually. If you go back to my original product equation, I know that this guy is a concave down parabola. Okay, because there's a negative a value. And then from part C, I know that my maximum occurs at the x value of 45 And then from part D, or that was part D, on the second part of part D, I know that my height, my y value occurs at this 506.25. Okay, so that's visually what we're looking at here. Okay. All right, golf ball. This is one of my favorite types of questions. The golf ball question. So you've got a golf ball, it's hit so that the height, which is called h of t, measured in feet after t seconds is, and it gives you an equation. Now, before I move any further, when you look at that equation, what do you automatically see about that equation? What can you automatically tell is happening? Just by looking at the equation. Yeah, it's got to be a concave down parabola. By the way, that is kind of the path that golf balls take. Okay, I mean, granted, it's probably more like this. All right, but still, that is the path that a golf ball is going to take. So, so that makes sense. All right, let's read what we're supposed to do with that. What's the initial height of the golf ball? All right, now put yourself on the golf course. Where is the ball before you hit it? On the grounds. How high is that? 0 what? 0 feet. By the way, I am a big advocate of labels. Okay. So make sure that you're putting the right label. Sometimes my lab puts it in for you, but let me tell you, if I can figure out a way to make you put it in, I will. Okay. Letter B, how high? Let's stop right there. How high? So what are we looking for if it says how high? We're looking for the height. Does that mean we're going to look for T? No, we're going to look for height. H. Okay, so let's keep on reading. How high is the ball after 1.5 seconds? Okay, well, if I have my equation, what am I going to do with that? Plug it in. Yeah, so I got h of 1.5 seconds is equal to negative 16 times 1.5 squared plus 60 times 1.5. All right. You punch on buttons? Wait, that's impossible. No, I can't have a height that's negative. Gotcha. Okay. So Dylan, that's a great example of make sure that your answer makes sense before you just automatically write it down. He tells me that my golf ball's height is negative. Wait a second. That's a really big divot, right? I mean, so what's that? It went in the ground. Yeah, I mean, like into a hole in the ground, negative 27 feet. So automatically be looking at your answer. Ask yourself, does my answer make sense? If I'm on the golf course and I say, how high did my ball go? And yes, negative point. Okay, so 54 what?
8.
There you go. Don't golf in the Grand Canyon. Other than the fact that you might hit someone. All right, so C, find the maximum. All right, let's stop right there. What's your clue about maximum? What should you be thinking the minute you hear the word maximum? Vertex. Find the maximum height. Now wait a second. Which piece of the vertex represents the height? Remember the vertex is called HK? Which of those pieces represents the height of my ball? It's the K value. Height is a Y value. Okay, so I need the K piece of it. So yeah, don't fall into the trap that says, oh, it's H, so that H must mean height. Because that's not the case here. All right. So I need the K value of my vertex. Well, what do I have to find first to find the K value of my vertex? I got to find the H value of my vertex. Okay. So we've got, how do I do that? Okay. So negative B, this is going to be my H value, negative B over 2A. So that's going to be negative 60 over negative 32. All right, 2 times negative 16 on bottom. Can somebody either give me, let's see, the reduced value would be 30 over 16, which is 15 eighths. Okay. Or what's the decimal value of 15 eighths? No, it's 1.875. Isn't it?
Yeah.
Does it say anything about rounding? So what happens then, okay, so Dylan, what I want you to do, so Zoom, if you guys didn't hear what Dylan said, he said it was 1.88. Can you continue, and I want you to find the maximum height of the ball using yours, and I'm gonna find the maximum height of the ball using the accurate version, or the drawn out version, and we'll see how far apart we are in our answers. Okay, so now to find the maximum height, I need my K value. So that's going to be H of 1.875. I'm going to need someone to punch buttons for me. Negative 16 times 1.875 squared plus 60 times 1.875. All right, who has that? 56.25. 56.25 what? Feet. Dylan, what did you get with the 1.88? I gotcha. So in this particular case, Dylan, that almost worked out in your favor, but it is different. Okay, and so it's not always going to be close enough for you to still get the right answer. Because if it had been 56.44, you would have gotten a different answer. So here's the overall rule, folks. You never round inside of a problem. You can round for a final answer if the directions tell you to, but you should never round inside of a problem. Have you ever heard that old story about the ship who the pilot of the ship was just simply half of a degree off course? Okay, now half of a degree is like nothing. And yet that angle is going to get wider and wider and wider and wider, 500 miles down the ocean, and he's going to be considerably off course. What happens with rounding inside the problem is you're just a little bit off course. And every step you take is going to take you further off course. So you always want to use the most accurate version inside the problem, only round at the end if the directions tell you to. All right, part D, first 2 words, how long? All right, so how long is not the name of a Chinaman, okay? How long, what are we looking for here? Time. So that must mean I need to know T, okay? So how long will it take for the ball to hit the ground? Okay, so let's think about this again. Here's a picture of the path the ball took. Remember, it started on the ground. It ends on the ground. It will not stay suspended forever. So then how high is it when it hits the ground? 0 feet, right? Okay, so now this question told me what my h was. It was a little hidden, you had to think about it. But when it hits the ground, height equals 0. So now I can go back to my equation. I can plug in my h value that is 0. So it's going to be 0 equals negative 16t squared plus 60t. And now I can solve for t. Hey guys, this is a quadratic. According to section 3.3, how many ways do you have of solving quadratics? There's 4 ways. What are they? Name one. Completing the square is one. Somebody else name another one. Quadratic formula. Somebody else name another one. The zero product property, and there's one more. The square root method. Okay? Now, I look at this. I could use, the only method I can't use on this is the square root method. Okay? The square root method requires that you only have one variable, and I've got 2 variables up there. Okay? So that's the only method I can't use. And so what am I going to use? Because in this case, I'm not going to tell you what to use. You get to pick any money, no. I'm going to choose factoring, the zero product property. Okay? Because I have a GCF that I can pull out. All right? So keep your 0. By the way, zero product property only works when you have 0. Go figure. So what's part of my GCX that I can factor out? A t. What's something else that I can factor out?
2.
What did you say, Becca?
2.
Okay, I can pull out a 2. Is there something bigger I can pull out? Yeah, I can pull out a 4.
Wait, what happens if you use a 2?
Nothing.
Oh, okay.
More work.
Oh.
Yeah, the more you can pull out, the better. And I'm also going to pull out a negative, okay, because my first term is negative. If my first term were positive, I would not pull out a negative. Okay, so you remember factoring is just simply done by dividing. So when you take a negative 16t squared and you divide by negative 4t, what's left over? A positive 4t. And then when you take a positive 60t, well, let's take this one at a time. Factor out a negative, what do you get?
Negative.
5 minutes. You get a negative. Factor a 4 out of the 60, what do you get?
15.
And factor a t out of the t, I don't need that anymore, right? T divided by t is 1. Hey, what's a good way to check my work on this? Like, let's say that I'm a little bit nervous that I factored wrong. Like maybe factoring isn't my greatest strength. What would be a good way to check your work just to make sure you factored correctly?
Distribute.
Yeah, redistribute. If I take negative 4t and I pass it out to both of these guys, I should get what I started with. Okay, so this is a good way to check your work. Okay, so zero product property says take each piece and set them equal to 0. Make yourself some little mini equations. So I've got negative 4t equals 0. There's my first factor equals 0. Or 4t minus 15, there's my second factor equals 0. This is the zero product property. I gave it to you on video. This is a review from Math 101 and Math 102. All right, so that's why I didn't take the time to teach it in class. Okay, so if I solve both of these guys for t, well, solve your first mini equation. What do you get? T equals 0. Oh, well, that's not such a shock. At time equals 0, at the beginning, the ball was on the ground. We already knew that. Okay, so this is not the piece we're looking for. Let's go to the next one and solve. So you're going to add 15, divide 4. Okay, now, so let me leave it like this for just a minute. If I asked you, about how long does it take you to get to Walmart from school? And you said, oh, Ms. Roberts, it's really not that far away. It takes me about 15/4 of a minute. I mean, I'm a geek and I would look at you like you were nuts, okay? Because that's not how we talk about time, okay? So either 3.75, as Dylan said, or 3 3/4, either one of those would be good. So this would be a time November where 15/4 is a good answer, but because it's time, we would never answer like this. My lab would not accept this as an answer because it doesn't make sense, okay? And by the way, let's go back to the blank. 3.75 what? Seconds. So that's how long the ball was in the air from start to finish, okay? All right, example number 5. Find the lengths of the sides of the lot of land in the figure. Okay, now what kind of a figure is this? And I'm gonna go ahead and give the first answer. It's a triangle. Okay, that's not what I'm looking for. So let's be a little bit more specific. What kind of a triangle is this? You're having to revisit high school geometry here. The right triangle. Do you remember that right triangles have legs and they have a hypotenuse? Whoa, oh goodness. Okay, so do you see what the right angle is? The perfect L? Okay. The two sides that touch the right angle, those are called legs. The side that does not touch the right angle is called a hypotenuse. Now, what kind of a formula did you learn in high school geometry that was helpful with these? Good. A squared plus B squared equals C squared. And that's great when you have A's, B's, and C's, but I ain't got any of those. So when I used to teach high school geometry, I didn't teach A squared plus B squared equals C squared. I taught leg squared plus leg squared equals hypotenuse squared. Because then it didn't matter what letters were on it, as long as I knew what a leg was and what a hypotenuse was, I could easily know what to plug in. Okay? All right, so leg squared plus leg squared. Let's look at those two first. What's one of the legs? S. So there's my leg squared. Plus, what's the other leg? 2s plus 20. Is it proper for me to write it like this? 2s plus 20 squared. No, because what am I squaring there? Just the 20. I need to square the whole leg. Is equal to the hypotenuse squared. So what is that?
2s plus 30 squared.
Good. 2s plus 30, the whole quantity squared. Okay, now you'll remember that a square means I have two whole quantities. Two whole quantities says you've got to do what?
Multiply by.
You got to foil. You got to foil. Okay, so you've got s squared. If you FOIL 2s plus 20 times 2s plus 20, if you need to go to scrap work and do that, that's fine. Okay, so first outer inner last, this is going to be a 4s squared plus 80s plus 400. If you guys don't know what I did there, I foiled mentally. Okay, so just go over to scrap work. If you forget how to foil, or if you don't see it, go to scrap work. You'll get the same thing if you foil correctly. Okay, and this is going to be equal to, I got to foil on the other side as well. So this is going to be 4s squared plus 120s plus 900.
Can you go ahead and simplify that one side to 5s squared?
You can.
Okay.
You can, and that'll be what I'm going to do next. Now, I like what Becca said. I'm going to go a little bit different route than what Becca did. I am going to move everything to one side. I want to get standard form, you know, like ax squared plus bx plus c equals 0. And the first thing that I see is that when I combine a 4s squared and a 4s squared, when I move the one on the right over to the left, what are those two 4s squareds? What happens with them? They totally cancel. So I'm not even really going to pay attention to those two. I'm just simply going to be left with an s squared. If you had done what Becca had done and got the 5s squared, when you subtract 4s squared, you're gonna get a 1s squared, which is the same thing I got. Okay, so that's totally fine. And then I'm gonna take my s's and combine those. So I want my 120s to go to the left. So when you combine them, what do you get? A negative 40s. And then take the 900 to the left and you'll get negative 500. Okay. Next, we have to solve the quadratic. How many methods do we have for solving quadratics? 4 methods. I gotta tell you, I look at this in quadratic formula. Those numbers are too big. I don't want to do quadratic formula. I could do factoring, but I don't know the multiples of 500 or the factors of 500. Not offhand. I mean, 5 times 100. I know that one. Okay. But I don't really know those very well. 50 times 10. Oh, actually, that might work. 50 times 10 would probably work because there's a 40 in the middle. But what I am going to do is I'm going to show you, I personally would like completing the square on this one. And you say, Ms. Roberts, when is completing the square going to be best? Okay. 2 requirements. Do you see how my A out front is a 1? Okay, that's requirement number 1. If my A is a 1, I might use completing the square. Second requirement, my B should be even. So like if my B was a 5, I would not choose to do completing the square. Okay, it's just not as nice. But if my A is a 1 and my B is an even number, completing the square is quite nice. Okay, so let's run through completing the square. Again, this was on a video, okay, but let's walk through it together. So we have s squared minus 40s, that's just a copy. You're completing the square, how to, said move the constant over to the other side. Okay, so I'm gonna leave myself some space and that 500 I'm gonna take to the other side. There's no math involved in that step, okay? All I did was copy the first 2 terms and move the 3rd term to the other side. So no math yet. All right, next in your how-to, it said take half of B, all right? So what's half of B here? Negative 20. And then I'm supposed to square that number. So negative 20 squared gives you 400. And what do you do with that number now? You add it to both sides. So I'm going to add 400 to both sides. Okay. This is all in the how-to that I gave you already on video. Okay. Now, next it says to factor the trinomial. And there was a shortcut for factoring. You keep the variable. Do you remember what your half of B was? Negative 20, that's what goes next. And then you're going to square that quantity. That's the shortcut. You don't even have to take the long way to factor it. If you completed the square properly, that's how it's always going to work. And then the next thing in the how-to says combine your terms on the other side. So that's 900. Okay. Now, that's the completing the square part. I'm finished with completing the square. But what's next is I need to continue solving using the square root method. This is the, I like to call it the onion layers, where you're stripping away the outer layers and sending them over to the other side. So when you look at that last statement, what's the outer layer?
I don't really understand the terminology, but I was just thinking you could just square both, or sorry, not square root both of them.
Yeah, because the outer layer is the square. That's the biggest thing that's happening. And the only way I can undo a square is to square root both sides. Now, what is it that you need to remember when you square root both sides? Plus or minus. So I've got s minus 20 standing alone now is equal to plus or minus 30. Okay, so what's the next layer that needs to be bumped to the other side?
20.
The 20 needs to be moved over, and I can do that by adding. So that's going to be S is equal to 20 plus or 20 plus or minus 30. Okay. Now, what's 20 plus 30?
50.
50. What's 20 minus 30?
Negative.
Negative 10. What did S stand for in our original picture? Well, oh, so I'm not asking what the label is.
One of the legs.
It was one of the legs. It was the length of a lot of land. Can your land be negative 10 meters long? No. So that negative one, we can throw that one out. We don't need that one, okay, because it doesn't make sense in our question. But let's go back to the directions. It said to find the lengths of the sides of the lot of land. Have I finished that? Am I done? No. So one of the lengths is 50 meters. But how am I going to find the other two? Plug and chug. All right, so if I'm plugging and chugging, here, 2 times 50 plus 20. What does that give you? Okay, so 2 times 50 plus 20, that side is going to give you 120 meters. And then the hypotenuse is 2 times 50 plus 30, which is 130. So a little bit of extra work there to find the other two sides. All right, any questions on that? Zoom, you guys got any questions? We good? All right, so then let's head on in then to chapter 4. So just as a side note, at this point, you are no more embedded question bonus points are available for chapter 3. Okay. By the way, on the last test, for some people, I was able to add as much as 3 points to their test grade because of the embedded question bonus points. Okay, just so, I mean, you have to watch the videos. You might as well get bonus questions for watching the videos. Watching the videos, remember, is a requirement. This is not optional. Okay, so if you have to watch the videos, you might as well get bonus points for doing it. So some people got as many as 3 points. The other way that you could earn bonus credit on your test is by working the practice test, and I talked about that the last time. Okay, so both of those things can earn you some bonus credit for your test. But the reason I bring it up now, it's too late for chapter 3, but it's not too late for chapter 4. Okay, so we're going to talk about some of the bonus credit that if it had been turned in by today, that could have been earned. Okay, all right, so chapter 4, some terminology. With each one, I'm not going to go through what the term means because that's on the video, but we are going to go through the examples because that's what you could earn some credit for. So how many terms are in this really ugly example that I've provided for you? There's 6. Dylan, which one are you missing, do you think? The X on the end, okay. The word degree, okay, so what's the degree in my example?
9.
It's 9. Yep, the highest power in my example is 9. Okay. Sarah, why did that throw you for a loop there for a second?
I guess because the 8 was at the very beginning.
Yeah, so this one's not written in standard form. I did not write the leading term first, okay, on purpose, to see if that was going to catch you. Okay, so be careful about that. All right, oh, I just kind of gave one away then. what is the leading term in this example?
2 square root of 3.
No.
2 times square root of 3x.
Yeah. So it's 2 root 3 times x to the 9th power. Leading term says it's the whole term. You can't leave any of the term out. Okay, it's the whole term that has the degree in it. All right, let's see, the next question. What are some of the coefficients in this example? I thought you said 5. Pi is a coefficient. What else?
-3.
-3, another one? -4. There was a 1. There was a -1. I didn't list all of them, but there's 6 of them. Every single term has a coefficient in it. Okay, so it looks like I only left out 1. Number 5. What is the leading coefficient? So I had leading term. I'm not asking about the leading term now. I'm asking about the leading coefficient.
2 square root of 3.
2 root 3. Good. And then last but not least, what's the constant? 1. So all of those questions there, all of those examples could get you embedded question bonus points, okay, just by filling that out. All right, so moving on, some properties. This is important. Some names of specific polynomials. We'll be using those names, so be familiar with those. All right, and then I walked you through extrema in the videos, maximum points versus maximum values. So make sure that you understand that. And let's head into some examples here. So using what the video said, once again, folks, I'm not gonna repeat what the video said. I'm not gonna, no, that's the wrong way to say it. I'm not gonna reteach the video, because for those of you who took your time to watch the video, I'm just wasting your time to reteach it. I'm not gonna waste your time. You did what I asked you to do. I'm not wasting your time for that, okay? So I'm not gonna reteach the video. The video's there so I can do some examples. So I'm headed straight for examples. If you haven't watched the videos for section 4.1, you're gonna be lost. Ms. Roberts is probably not gonna feel too sorry for you. I'll act like I do though. Okay, so make sure you're watching those videos. It's very, very, very important. All right, so let's see. Find local extreme points. Okay, so there's some pretty important words there. Extreme is an important word. Point is an important word. Local is an important word. Okay, so find the local extreme points of F. Notice that this picture here is my F picture. This picture here is my G picture. Okay, so I don't want you to say a word. I want you to write down for point A what you think the local extreme points of graph F are. And you're using what you saw in the video to do this. Just part A, local extreme points of F. Now, Zoomers, in a minute, I'm going to ask the people in class to show each other what they wrote down. I want you guys to put this in the chat. So just type it out in the chat. Part A only. Find the local extreme points of F. All right, once you have it written down, I want you to show someone nearby what you have. If you and the person nearby have something different, talk about why you think your answer is right, or let them talk you into why their answer is right. Okay, so if you have the same thing, no problem. But if you have something different, talk about why you feel like yours is right. Oh, I have nothing in the chat. What's going on, guys? Am I missing something? Did you guys chat? Are you giving me the silent treatment? Do you hate me?
I'm for pre-cal and AP-cal. Yes.
Okay. So let's see. Mackenzie and Dylan, you guys, you talk to each other. You guys have the same thing?
Yes.
Yes. Okay. What do you guys have? Mackenzie, go ahead and tell me.
I don't have, okay. We had the same like 1 point, but I don't know. I put all 3 of them, which I don't think is right.
Okay. All right. So what 3 points did you put, Mackenzie?
A, B, C, D, E.
Okay. So Mackenzie, why do you feel like you might be wrong? Just because Dylan had something different? Because that's a bad reason if that's the case.
I don't have faith in myself.
You don't have faith in yourself. Okay. So what made you put all 3 of those points down to begin with?
It's like I don't know, the minimum and the maxes.
Okay. All right. They're the 3 mins and maxes. Okay. All right. Dylan, why did you only put one of them?
So I only put C,
Okay.
just because that was the maximum, and I'm assuming the other ones was the.
What's the definition of extreme according to the video?
Oh. You're right. I just said I already all 3, then I'm guessing.
Okay. Let's see here. Abigail and Reed, what did you guys find out?
I think that extreme is the x-axis, right? So it'd be A, B, and E.
Okay, wait a second. You said extreme is the x-axis?
Or like the ones not like C, D, because they're the highest up, or like A, B, D, H, is the part that's like most extreme.
Interesting. And Abigail, do you agree with him? You agree with Mackenzie? Okay. Alice, Mary Alice, you agree with Mackenzie? Okay, November. What did you and Jacob find out?
I came up with, well, I thought it was CD, but I think, not CD, negative EH. I thought it was because it was the biggest,
It's the lowest.
the lowest,
Mhm.
but listening to them, I think that all 3 of them could be it.
All right, Devin and Justin.
All 3 points are local extremes
Why?
because they're either a maximum or a minimum. But I also think negative EH is an absolute extreme because it's the lowest point on the entire graph.
Okay, so what's the difference between absolute and local?
Absolute is the entire thing. Local is at a certain area.
Okay, so let's take a look then. Local is what local means in our English language, like your own little neighborhood. Okay, so like here, locally, is that guy the lowest value? Locally? Yeah. Locally, is that guy the highest value? Yeah. By the way, is that guy the highest value of the whole graph? No, but in his own little neighborhood, he's the big fish, right? How about this guy? Locally, is he the lowest value? Yeah. Overall, is he the lowest value too? Yeah, he's like Big Daddy, right? Okay, so what we're looking at here, Kenzie, and you guys might not have actually told me which ones are mins and maxes. Local mins at A, B, and EH And that is not a negative there. It's just the tail of my E.
Oh.
Okay, sorry. Yeah. So that you'll know why I only put EH instead of a negative EH. Those are my local mins because in their local little neighborhood, they are the low guy on the totem pole. And then I have a local max occurring at CD. Okay. Now the next one should be pretty easy then. What about the local extreme points of graph G? Zoom, I want you guys to get involved with this one. So let's see, Brianna, I haven't heard from you today. When you look at graph G, what would you say is one of my local extreme points?
J and K and M and N.
Okay, now Brianna, can you be a little bit more specific? What kind of an extreme is JK? Is it a local min or a local max?
Min.
Yep. So a local min at JK, and then a local max at MN. Okay. All right, part C. Find absolute extreme points for both graphs. Okay. So let's see here. Sierra, what's my absolute extreme points of both graphs?
I would say for the F, it would be EH.
Is what kind of an absolute extreme?
The absolute min.
All right, so we have an absolute min at the coordinate EH. And then for graph G?
I think that the JK would be an absolute min.
Okay, so you feel like JK is as low as it goes. There's no other point that goes lower than JK.
I don't think that it has.
Oh, so is the absolute min JK or is the absolute min doesn't exist?
I don't think it is because it goes off there.
Yeah, exactly. It gets to notice that graph G keeps going down and down and down and down and down. If you think you've reached the bottom, take one more step down. Okay, you haven't gotten there yet. So graph G has no absolute maxes or mins, neither one. All right, part D, find the absolute extreme values of graph F and graph G. Let's see here, Becca, what do you think about that one? The absolute extreme values.
I was gonna say for C.
Wait, your name's not Becca.
Yeah, I was just gonna say on the last part of it.
Oh, gotcha. Okay, hang on just a second, Becca. This will give you a little bit of time. All right, as you're scrambling, go ahead. You have a question about D, C, part C? All right, so Dylan's talking to himself. He's doing a great job and he's figuring out math all alone. He doesn't need my help. All right, Becca, now it's back on you. What about that absolute extreme value of graph F or graph G? Don't forget that you're muted, so.
Would it be AB?
Nope. Sorry. So, all right, I got a question. What's different about part C and part D? Because they're almost worded identically. Yeah, one says a point and one says a value. So Justin, what does it want?
Well, it wants the value. Like,
Yeah, but what's that?
It's a,
According to your video, read.
it's an all real number.
Look at your video notes.
The Y value.
Yeah, it's the Y value. Was that you, Brianna?
It was.
You go, girl. All right, so the Y value is what you're being asked for. You already found the absolute points. Now you're just looking for the Y value there. So what's the Y value that's the absolute extreme value? H. G, the graph G never had an absolute. So it doesn't have any points, it doesn't have any values. Okay. All right. The maximum number of turning points on a graph with degree n. All right, so let's talk about this for just a minute. Chapter 3 was all about parabolas, quadratics. What's the degree of every quadratic you've ever run into? Remember, this is what a parabola looks like. It's a what? A square. Yeah, a 2. Degree is 2. Okay. This would be a common cubic. Okay. Its degree is 3. So let's write this down here. My degree here is 2. My degree here is 3. This would be a common quartic. What was that word? Right. But what did it mean? 4th degree, 4th power. Now, let's go back to the degree of 2, the quadratic. How many turning points does this guy have? Just 1 turning point. Keep that in mind. Okay. How many turning points does this guy have? 2 turning points. How many turning points does this guy have? There's 3 of them. You've got 1 here, you've got 1 here, and 1 here. All right, 3 times that it turns around. Now, so can we come up with a pattern here? If my degree is n, and I gave you an example of a degree of 2, a 3, and a 4, what is the maximum number of turning points? N minus 1. It's always 1 less than the degree. So what's the maximum number of turning points for a polynomial that has a degree of 17? 16. Let's hope we don't have any of those though, right? Now, this is a maximum number, okay? This doesn't mean I have to have that many turning points. It just means I can have up to that many turning points. Think back to your parent list. Do you remember your parent list, the cubing parents? Bless you. The cubing parent looked like this. If I just graph that, how many turning points are there? I mean, yes, it's a cubic. It can have up to 2 turning points, but really there's no turning points there. Okay, so I can have up to 2, but it doesn't mean I'm gonna actually have 2. All right. Okay, ends behavior. So let me get over here in front of the camera. End behavior, the big deal. What's happening way out on the ends? Okay, I don't care about the ups and the downs. I just want to know what's happening way out on the end. That's why it's called the end behavior. Okay, so when x is all the way down there at negative infinity, and when x is all the way down there at positive infinity, what's my graph doing? Is it going up or is it going down? That's what I really care about. Okay, now we already know what the quadratic does from chapter 3, right? So what does a quadratic ends? What are the 2 choices for the ends of a quadratic? The 2 choices for the ends of a quadratic. Think chapter 3 that you're going to have a test on Thursday. Yeah, both ends are either going up or both ends are going down. And in the quadratic for this chapter, how did you know if both ends were going to go up versus both ends going down? How could you look at the equation and tell? It was my a value, right? Oh wait, we have a name for that. Now in chapter 4, the very first page of notes, the first 6 terms, what's the a? What's another word for a? Okay, close. The leading coefficient will tell me. And so that's what you had from your video here. Your leading coefficient tells you if both ends are up, both ends are down, 1 end up, 1 end down. Okay, so again, go back to your video to get this. The weird one is the odd behavior. You have to pay attention. Am I overall going uphill where I'm starting at the bottom and I'm working my way to the top? Or am I starting at the top and working my way down to the bottom? Okay, that's the difference between the 2. You're always moving from left to right. Always moving from left to right. Okay, all right, so here's another little collaborative example here. Work on your own first, okay? And then either chat me or you're gonna show somebody else. This is a matching discussion here, okay? You've been given 4 equations. You've been given 4 graphs. No calculators on this one. And you're supposed to match the equation to the graph. Hint. Look at the degree. Look at the leading coefficient. Figure out what the degree is. And think about the leading coefficient. All right, now start discussing. One of these days, I'm gonna learn how to put you guys in a group together. I can do it, I just don't know how. And then you can be your own collaborating group.
They're both going the same direction.
I just don't know how.
That makes sense.
Yeah, I do.
Does anybody else know how to make a group in Zoom?
I did too. My calls were 3 calls.
You just don't know how.
Same direction. And then opposite direction.
It was labeled as a breakout room.
You know what, I think it's because this is not the host computer. Thanks for your answer.
And then like if it's a negative, coefficient.
Yeah, I think it's because this isn't the host computer. I'm trying to do it on here, but my iPad doesn't show Zoom. So, okay. I'll figure out how to do that then. I'll figure it out. Pull up the chat here. Good, Brianna. Oh wait, no, that was the last one. Okay, so Becca, I'm here so far. Okay, so what are the thoughts? Dylan, why are you shaking your head?
I have no idea.
Okay, so that means you're gonna do the first one then, Dylan. Okay, so Dylan, can you look at the function for f of x? What's the degree? 4. Is the leading coefficient pos or neg? Positive. All right, so you're gonna go back to your notes from the video and you're going to decide.
Oh, that's why, because that's on another page, so I wasn't looking at that.
So tell us, if my leading coefficient is positive and my degree is 4, which of these 4 choices should I choose? Of these. So let's go with top left, top right, bottom left, bottom right. Top left, okay. So what does that match with here? Oh, okay. I thought you didn't know how to do this.
I'm bad at missing things like that.
Because
I was doing that with negatives and like one of those other classes.
Okay. All right, Jacob, you're next. Oh, yeah, you, Jacob. Okay. Jacob, G, what is the degree? And what is the leading coefficient? Okay, so Jacob, what is my choice then? If I have a leading coefficient that's negative and the degree is 6. Okay, so this one right here. Here, let me circle that on the iPad so Zoom can see too. So this one is the one you're choosing. Okay, what did you say your degree was? Ah, this one here? Okay, and why are you changing your mind other than the fact that I looked at you? What's even? The degree is even. Yeah, so it's got to be one of the top 2 choices. Okay, so then Jacob, why? Because it looks like the one on the top right. Yeah, exactly. Okay, November, h of x. What's the degree? And what's my leading coefficient?
3.
Okay, so then which of my 4 choices is this going to be?
It's gonna be the left bottom one.
Okay, bottom left, so this one right here. Okay, and so what does that match with on here? B. Okay, Blake, you're up. Okay, well, a process of elimination says that K is gonna be D. Okay, spoiler alert. Blake, what is my degree?
7.
And what is my leading coefficient?
-1.
Okay, and so which of these 4 choices does it have to be then, Blake?
Bottom right.
The bottom right. I know you guys can't hear him. So which one is that? Spoiler alert. Yeah. Okay. So I don't need a calculator to figure out which one goes with which. Okay. All right. The x-intercepts. Now I said this in chapter 3. So this is important. Did you notice that all throughout 4.1, I kept going back and reviewing chapter 3 because you have a test on that on Thursday? Okay. So what are some other words that mean the same thing as x-intercepts? Solve. What else? Zeros. What else? Roots. And there's one more word that's a lot like solve. Solution. Solution. So what do I have here? So not what I thought I was writing down. Can see them on what? Hold on. X-intercepts are the same thing as real zeros. You can see them on the x-axis. Okay, well, that was a good review, even if that's not what went in the blank. This is what happens when you don't bring your notes with you. I didn't know what was there. But it was a good review, wasn't it? Because you're gonna you're gonna need to understand that concept for your test on Thursday. So look at my pictures out on the right. What is the degree of the first picture? Okay, it's 2, because that's a lot like everything we did in chapter 3. How many? So let me write that down. How many x-intercepts could I have? I might have 2 if my x-axis goes like this, right? And that is going to be my maximum number. But what else? How many other x-intercepts could I have? Where would it have to be if it was 1? Yeah, like right going through the minimum point. And then what else could I have? None where it's way below. All right, but my maximum number of x-intercepts is 2. What the example picture on the right next? What's a good, what's a possible degree for that guy? 3. Now think about where your x-axis could be. Okay, if your x-axis is right here, how many zeros, x-intercepts, do you have? 1. If I move it up a little bit, how many x-intercepts do you have now? 2. If I move it up a little bit more, how many x-intercepts? 3. If I move it up a little bit more, and then more. Yeah, so what's my maximum number of x-intercepts? It was 3. Okay. And last but not least, this is where we'll be stopping today. What's this example degree here? 4. Okay, so the degree is not negative. It's the leading coefficient that might be negative. Okay, so here, let's get my x-axis here. If I'm way down here, how many x-intercepts do I have? Ah, look at that again. Yeah, there's 2. Yeah, right. Okay, and then if I move it up a little bit, how many now? And how many now? And how many now? 1, 2, 3, right? And how many now?
2.
How many now?
1.
How about now?
0.
Yeah, so what was the maximum number there? 4. So can we see a pattern? Yeah, the maximum number of intercepts is always going to be the same as the degree. Okay? All right, guys, I will see you on Thursday for the test over at HSB 104. Yep, same place. It'll be that way until I change it.
Okay.
Okay? Basically, if I ever get to the point where there's only 12 in the class, we'll have a test in here. But for now,
I won't be late.
good. What's that? Yes, you were. Thank you. All right, Zoomers, I will see you guys on Thursday.